Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode problem, and the problem's name is count nice pairs in an array. So you are given an array nums that consist of non-negative integers. Let's define reverse of number x as a reverse of non-negative integer x. For example, reverse of 123 will be 3 to 1 and 120 will be 2 1. So leading zeros are not counted. So if we go on reversing this number 120 will be 0 to 1 reading from this side. So this will not be counted, so your number will only be 21. Okay. A pair of indices is nice if it satisfies the following conditions. What are the conditions? The ith index, the first index should be lesser than the second one, and this condition should hold. What is the condition? The condition is that this is the condition. Okay. So this condition should be holding, and your ith index should be lesser than the jth one. Okay. These two conditions. So let's have a look, and then you have to return the number of such nice pair of indices. And it is saying that answer can be large, so you should be returning it with respect to modulo 10 raised to power 9 plus 7. Okay. And let's have a look at the constraints. So the constraints here are length of the nums array that will be given to you will be of order 10 raised to power 5, and the elements in this array will be ranging from 0 to 10 raised to power 9. Okay. So first of all, if we make some observations, we can rearrange this equation. How we can rearrange? We can take this particular expression and take it to the left hand side. So it will be something like this. Okay. And then you can take this one and move it to the right hand side. Okay, I'm moving it to the right hand side. Now the modified equation becomes this. Okay, so this should satisfy. I just rearrange the terms in the equations. Okay, so this is your modified equation. Now if you see that our numbers difference with its reverse number we are interested in. Okay, and let's say a number given to you is 1 2 3. This is nums of, let's say, I, or let's say this is nums of j. Okay, and what will be the reverse of 1 to 3? It will be 3 to 1. So whatever the difference that you will be getting here, uh, let's call this diff. if this diff is being repeated earlier also, if you have seen this difference earlier also, then the number of times that you have seen this difference earlier will be the number of pairs that this nums of j can be contributing to. Okay, so what I'm saying is number of times you have already seen this difference earlier, moving from, or say, traversing while traversing your given nums array from left to right direction. Why we are taking this particular direction? Because it is mentioned that your ith index should be lesser than the jth one. So if you are counting the contributions of jth index, then you should be traversing the array in left to right direction. So that only whatever number of times you have seen this difference earlier will be your ith indices that can be paired with this jth index. Okay, so number of times you have already seen this difference earlier traversing your given nums array from left to right direction. Let me quickly take another slide. Will be the number of pairs nums of jth nums of j will be contributing to. Okay, so in that case, we will simply be increasing our, let's say we are defining another variable pair count that we will be returning from our function. So we will increment our pair count based upon the number of times you have seen the current difference. And what will be the difference? Difference will be nothing but nums of this j minus reverse of nums of j. Okay, and what will be the whatever will be the difference frequency, your pair count will be incremented by that difference frequency of this particular difference. Okay, so this is how we will be approaching the problem. Now let's have a look at the implementation of the problem. Okay, so the implementation is quite precise, quite short actually. So let's have a look. So pair count will be the variable that you will be returning from your function. Okay, and then difference frequency will be the number of times you have seen a particular difference. Difference frequency will store the number of times you have seen a particular difference. Okay, and then according to the modified equation, you will be finding the difference. According to the modified equation. And what is the modified equation? This one is the modified equation. Okay, we will find the difference, and the number of times we have already seen the current difference will be the number of pairs that nums of index can be contributing to. Okay, so in that case, you will increment your pair count by that number. So you will increment your pair count by that number. Okay, and if you may ask, what is this difference function? Find not difference function, find reverse. It is just finding the reverse of a number. Okay, this is very simple logic. You are extracting a digit from the very end one by one, multiplying it by 10 and adding those digits. For example, if the number given to you is, let's say, 123, then you are picking one by one these digits and you are doing something like this. Okay, so it will be 3 to 1. And how you are picking? Let's call this a num. So you are just doing num percentage num modulo 10. It will give you the last digit. Okay, and how you are reducing the number? You are just doing uh, dividing it by 10. So if you divide this by 10, you will be getting 12 in the quotient. So this is how this thing is worked. Okay. So if you may ask, what will be the time complexity and the space complexity here? Okay, the time complexity can is order of n here only. Why order of n? Why we are not counting this? Because if you see that only 10 raised to power 5 is the maximum number that can be allowed. And here what we are doing? We are dividing by 10. Okay. So if you take logarithm of base 10 of 10 raised to power 5, it will be 5 only. That makes this loop will be running only 5 times. which loop I am talking about? This particular loop. Okay, so it will not matter much. And this is just a single for loop running till the size of your given nums array. So it will be order of n, where n is the size of nums array given to you. Okay, and if you may ask what will be the space complexity, then it will also be order of n because of this difference frequency. If let's say all the differences are unique, you have not seen a particular difference before, then in that case it will be order of n also. Okay, so this is what the space and time complexities will be. And if you are having any doubts, please feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.